All the participants, our next resource person is Uppala Setu Rukmini Ramsar. He completed his Bachelor of Technology in Mechanical Engineering from Lakiriti Balreddy College of Engineering, Mailavaram in the year 2005, and he did his Masters in Machine Design and Analysis from National Institute of Technological, Rourkela, Orissa in the year 2008. And coming to overview of the work experience of Sethuram sir, he joined HAL as design trainee in 2008 July, served for 7 years and worked on aero gas turbine engines. He involved in design of light combat aircraft starter, that is gas turbine starter unit, and he has a good experience in gas turbine engine testing, troubleshooting, production support, and work design. And he joined Quest Global in November 2015, worked for Rolls-Royce, Siemens, Gamesa, and renewable energy clients. Good domain, Sir has good domain knowledge in aerogas turbines and wind turbines, and present he is working for GE Vernova client for gas power sector. Now I request a resource person to take over the session.
Thank you. Thank you, everyone. Hello. My voice is audible.
Yes, your voice is audible.
My screen is visible.
Make it full screen.
Yes, sir.
Okay. So I want to show some overview about hydrogen generation through wind energy. So in this topic, I will cover all these things about what is hydrogen, about the hydrogen application of hydrogen gases, and what is green hydrogen, how to generate hydrogen by electrolysis, overview about wind turbines, and some modules in the wind turbine. I think in this one, first three might be repeating for you, everyone, might be. So even then, please focus on this one topic. Maybe some points may be new or old. Okay. So I want to tell something about hydrogen. So hydrogen is the simplest element and the first element in the periodic table. As you know, from the +1 and +2 onwards, we studied so many things about elements in the periodic table. So everyone has studied about hydrogen also at the same time. And now why we are focusing more about hydrogen, because of the more and more pollution due to the fossil fuels and green gas emissions. So the entire world is now trying to reduce the pollution from the air, water, and environment. So to make everything as environment friendly, so everyone is studying about this hydrogen and renewable energy, all those things. So about the coming back to hydrogen, so it's an abundant element in the universe, which is about 74% by mass and 90% by volume. Means it's telling about entire universe. Means outside of the Earth also more hydrogen is available. It's not only within that, but within the Earth, that the percentage of hydrogen availability is very less, because hydrogen is very lightweight, so it will easily escape from the environment. So it's because high diffusivity. And general properties will be like colorless, odorless, tasteless, flammable gas, and non-corrosive, non-toxic in nature. But it can act as a asphyxiant, means if hydrogen gas is leaked in the environment, it will displace the entire oxygen in the surroundings. So if we are not having oxygen, it's very difficult for us to survey, right? So it will create some catastrophic if hydrogen is leaked in the air. That is the meaning of the asphyxiant. And its density is light, that is 0.08 kg per meter cube, that is 14 times lighter than the air. And it's very rich in the energy per unit mass. If that 120
Sethuram sir,
yes.
Your slide is
Our
changing
slides
or
not.
not?
No, same. First slide only I'm explaining about the hydrogen.
Which
Which slide you
slide?
are visible for you?
It
Which
is
slide you can
only
see?
first slide only.
Yeah, same thing. In that only I'm explaining, right?
Okay, okay. Make it full screen.
Yes.
Just click the hide button into hide at the bottom of the
Okay.
screen.
Yeah.
Okay, thank you.
Okay. So density is very less. It's 14 times lighter than air, and it is richest energy per unit mass. Means if you consider with respect to the mass, the energy is very high, but with respect to volume basis, the energy is very less. So if we compress the hydrogen very huge, very high pressure, then the energy per unit mass will be more. So that's why storing the hydrogen is difficult and making that into liquid state also difficult. Some process will be difficult for the hydrogen. So that's why more and more research is going on this hydrogen. So hydrogen gas has some wide varieties of application, like in industries, transportation, and space application, power, refineries, heating. So few things I have explained here, like where it is used in the industry, like it's used in refineries, like hydro denitrogenation work and hydrocracking, reduction aromatic content of the crude. These are the applications in refinery, and it is also applicable in chemical industries, like to produce ammonia and methanol. And in fertilizer industry also it is used. In semiconductor industry also it will be used. In food industry also it will be used. But all these things are from past long time it is there, but we are more focused in the transportation and power generation. So more research is going on in the transportation. In transportation, hydrogen we are using it as a fuel, and as well as in power sector also, there is more research is going on for this hydrogen. So it is used in gas turbines for stationary fuel cells also, because of the intermittency of renewables. Means whatever you're using the renewables like solar or wind, it will not deliver the power constantly at 24 by 7 or 365 days. It won't deliver the power. Suppose if we take a solar power, where our sun is there, at the time only we'll get power from the solar panels. If it is a cloudy also, it will be cloudy also it will come, but that light intensity will be less. So at the time also the power production will be less. In the suppose if we take wind energy, whenever wind flow is there, then only we'll get the power generation from the wind turbine. Otherwise, if there is no air, then also we will not get the power. So that intermittency means it will not stable for entire time. So at the time we will have to combine the things, means sometime power from the wind energy, sometime from the solar panels, and sometimes we have to make up that power requirement with the help of this hydrogen gas. So hydrogen can be used for long-term large-scale storage. So whatever we produce power from the wind and solar, we can make that power to generate the hydrogen. Then we can store that hydrogen. Suppose one more example I will tell. So actually in Germany, they are producing energy from the wind turbines. Okay. So they are creating one kind of volcano. So to store the energy, it is called New Stone Age. This project is under research. So what they are doing, they are creating one concrete building 22 meters long, 11 meters wide, and 11 meters high. It's around the size of the Olympic swimming pool. So they are doing in the Germany. So what they are doing with that volume of that area, they are filling that entire thing with the volcano rocks. So with the volcano rocks, what they will do, they will use that whatever energy produced from the wind, they will use that energy to make the rocks into liquid, means like they are making it as a lava. So whenever they want that backup, means if power demand is more, then they will use that lava to produce back to electrical energy. So that is the project doing by wind energy company called Siemens Gamesa. Means my client only, they are doing this research. Okay, it's still under research. So that also one of the thing they are doing, means this wind energy, it will not come continuously. Sometimes it will produce huge energy, sometimes it will produce zero energy, so it won't have any stability, right? So for that purpose they are doing this one. They are doing, take whenever energy is available, they are making that energy to transfer to the grid. Always whatever extra energy is there, they want to storage in other form. Means in this case they are storing that energy in the lava form. So similar way, if this one, some alternative is like this hydrogen, if they have got more energy from this wind and solar, they have to utilize that energy to create the hydrogen gas and store that hydrogen gas as the backup. So they can, whenever that energy demand shoots up, they can use that hydrogen gas to generate the power. Always some are also R&D side are going on right side. Here it is they are making artificial lava, artificial volcano mountain, so that they can store the entire energy whatever they got in the generation. So this is the under similar to hydrogen as a backup. So this one volcano rock storage also one more backup of the entire energy what they produced. Okay, so I feel hydrogen is very much easy because you store that hydrogen wherever you want in the tanks. But creating that artificial volcano mountain is difficult and tedious process. So in that case also, that hydrogen gas is very much suitable for the requirement. So we know how now what is the purpose of hydrogen, why you want to use it. So you got some idea. Then that producing the hydrogen also some so many processes are there, like hydrogen generation from renewable energy like solar, wind. This is called green hydrogen, and the same hydrogen can be produced from methane. Same hydrogen can be produced from natural gas. Same hydrogen can be produced from black coal or brown coal. Same thing can be produced from nuclear energy. So based on the source of the, I mean, based on the sources or process, they name it differently, like green hydrogen, gray hydrogen, blue hydrogen, brown hydrogen. So, but more importance will be in the green hydrogen because of zero pollution, zero toxic gases emission. So, entire world is now moving towards the R&D or generate, giving preference to generate the hydrogen based on the uh, solar and wind. So now we come to know how to produce hydrogen with help of solar or wind. Then we should know how to generate hydrogen by electrolysis. So this electrolysis is the purest form of generating hydrogen. Means almost 99.99% that pure hydrogen will come with the help of this electrolysis process. So I think you people know the electrolysis process. So just I am showing the overview of this process. So here we use the water as water will be converted to hydrogen and oxygen with the help of electrolysis. We'll get the hydrogen from the water. So here also so many processes are there, like mixing the acid, mixing the base, so that conductivity in the electrolyte will be increased, so that different processes are there. I'm not focusing all those processes. I'm just telling how we get the green hydrogen. We get the green hydrogen with the help of the electrolysis process. So now we come to know how to produce green hydrogen, what is the advantage of green hydrogen. Now we come to the main topic called how to generate energy from the wind turbines. So wind turbines, the energy which is generated from the wind turbines is the input to the hydrogen generation. Like from the electrolysis is the input is the wind energy turbine electricity from the wind energy. Okay. So overview of the wind turbines. So wind is nothing but flow of air. So wind turbines principle is like wind energy. It's like opposite to the fan. So in the fan, that input is electricity and output is the air from the fan blades. If we reverse that one, in wind energy, in wind turbine, that input is wind energy and output is electricity. So in wind turbines, the kinetic energy from the wind is converted to mechanical energy or shaft power, and the mechanical energy is converted to electrical energy or electricity. So this is the basic principle in the wind turbines. So how we get the wind? Wind as source of energy means how we get the wind. Wind is simple air in the motion. It caused by uneven heating from Earth's surface by the sun. Because the Earth's surface is made of different types of land and water, so it absorbs sun's heat at different rate. For example, uneven heating can found in the daily wind cycles. Wherever the high temperature is there, that surroundings air will get evaporated. Then it will create some vacuum kind of thing. So wherever the cold air is there, that will come and occupy that wherever air is escaped due to high temperature. So with this, like this, that air will move faster to the from cold region to hot region. So if that difference is more, means high temperature and cold temperature difference is more, means that the velocity of the wind also will be more. Okay, so the more wind speed means more velocity of the atmospheric air. So wind energy is the kinetic energy associated with the movement of atmospheric air. So we used this wind energy from long time, like hundreds of years. We use it for sailing, grinding grains, and irrigation. Now more focus is on how to generate electricity from this same wind. Okay, that wind energy converts kinetic energy into useful form of power. So we'll come across some few terminologies like what is wind machine, what is windmill, what is wind turbines. So wind machine converts wind energy to useful form of energy. Windmill works on the principle of converting kinetic energy of the wind to the mechanical energy. And wind turbines transfer the energy in the wind into mechanical power, then that mechanical power convert to electrical power. So for each and every term having different meaning, like what is wind machine, windmill, and wind turbines. And we will go further about this one. Wind machines are generally classified in terms of orientation of axis of rotation. Means we have different kinds of wind machines like horizontal axis machines and vertical axis machines. These horizontal axis machines are like this. Means it is the parallel to the direction of the wind stream. Okay, so rotor axis horizontal and can be adjusted so that it is parallel to the direction of the wind stream. And horizontal wind axis windmill can further classify into single blade, double blade, multi-blade. And in otherwise, we can classify as also onshore wind machines, offshore wind machines. Onshore means that wind turbines, whatever installed on the land is called onshore, and whatever the wind turbines installed on the seashore, or not seashore, on the sea water, we call it as offshore wind turbine. And other kind of wind machine is like vertical axis wind machine. This is the simplest modern type of windmill which works like cup anemometer. You know, right? Cup anemometer. It's like it will that anemometer will give the speed of the wind. Similar way, this vertical axis machine also will be there. That vertical axis means this one will be fixed. This axis will be fixed, and this blade will be rotate around this axis. And this has become popular because in the low wind speeds also it can work. But this one requires very high speed of the wind, and this one requires low speed. And a controller is required for wind orientation, no controller is required. Suppose this windmill is there, right? To get the power from this machine, this wind turbine has to face to the flow of the wind. So that for that one, it has to rotate this. This should be rotate. Then only that it will face the particular wind direction. Then it can that blades can rotate. For that one, controller is required here. Same is explained here. A controller is required for proper orientation. In the vertical axis, that problem would be there, so no controller is required. Variable speed power transmission is better control, and simple power transmission system from the rotor of the axis. Means variable speed power transmission means whatever whatever energy we receive from this wind turbine, it will rotate these blades. That blades rotation will not be constant speed, it will be variable speed. That's why we required variable speed power transmission for better control. So that for better balance and better control, we required variable speed power transmission for this one. In this case, that variation won't be that much, so simple power transmission system is sufficient. And here variable pitch can tolerate wider fluctuation in wind speed. Means here these wind turbines can take wide fluctuation of air speed. This one will be performed at a low speed only, so for low speeds only it will be more suitable. For high speeds it won't be suitable for the vertical axis. And this one will be lightweight, this one will be bulky. And why lightweight? Because if you power generation power in kg, that will be very less for this horizontal. For this one to generate more power, we need heavy structure and heavy machine. That's why it is too bulky and this is too weight. And high tower ensures greater wind speed. And in this case, we can go very high, very height will be very more. Means it will be more time, 2 times of the our cell towers, or 2 times more than the 3 times of the our available cell towers. That much height we can use this one. This one, that much height we can't go. It will be very difficult. I mean, it cannot sustain that much height. This vertical axis. Okay, now some general equations we will see. Power production from wind. The kinetic energy of a mass m moving at the speed of v is kinetic energy is equal to half mv square. We know this one from the +1 +2 classes. We know half mv square, and the power potential is mass flow rate into velocity square. So the mass of air passing through unit time through an area A with speed v is mass flow rate. Means mass flow rate is nothing but density into volume. Density is the rho density of the air. A into V means volume per rate of volume. That A into velocity, that is the rate of volume. And that A is this whatever area is there, right? This wind turbine, this will be the A. That from this tip to from center to this tip, this is the radius. If this radius, if you make one circle, that is the area of the that is the area we will consider for calculating the power production. Okay, so this is the A means pi r square. R means this is the radius, one blade length will be the radius. that is the capital A. So if we substitute this flow rate in this mass, then we'll get the power potential, means half rho A V cube. And it is, this is the power what we got from the wind. Then here one more condition is there, like it is not possible to convert entire wind energy into our required energy, because that whatever wind energy we got, it will not become zero, means portion of that wind energy only we utilize to rotate the turbine. Entire thing will not use it, right? So for that one, we have some calculations. Based on the calculations, we got that one as 0.53593. The theoretical calculations, that is power coefficient. So based on the experiments, all those things, they arrived one value like 0.593. So that is the power coefficient. So wind turbine, now if we consider the power coefficient also, then what is the power we got is half rho A V cube Cp. And here we have that air is density is constant, and this power coefficient is constant, and so half into rho into Cp. This half into rho into Cp, these three values are constant, so it will come close to 0.37. So if we consider this entire thing as K, then power what we got is power is Ka V cube. Okay. There will be other losses also for deliver before the energy is delivered due to bearings, gears, and other power transmission system. So efficiency of mechanical efficiency and conversion efficiency, like electrical efficiency, transmission efficiency, all those things also we have to consider to calculate the power generation from the wind. So finally, for that power P star is 0.37. This 0.37 got from this one here. 0.37 into efficiency of mechanical efficiency, electrical efficiency, and transmission efficiency. And V is velocity. Here V cube is there, right? Same thing. Here we made divided by 10 because it's in the form of kilowatts, in the units of kilowatts. If it is a watts, this by 10 is not required. If we want to make it in kilowatts, then we have divided by 10. So this much we can get, this much energy we can get from the wind turbine. This is the simple calculation only, there is nothing complex. And at the same time, we required other parameter like tip speed ratio. So tip speed ratio is the ratio of blade tip speed to the wind speed. This tip speed ratio is required because we have to compare two different wind turbines. To compare that one, we require this ratio, tip speed ratio. So the term tip speed ratio will be used instead of rotor RPM to help comparing different rotors. For any given wind speed, higher RPM means higher tip speed ratio. Typical value of tip speed ratio range from 1 to 15. And this ratio will be in the range from 1 to 15. By using the TSR, we can ignore the rotor RPM and diameter, considering rotor performance in a generalized discussion. So this ratio is very useful to generalize the things, means generalize things. It's not too many dependence won't be there to compare two different rotors. If we know the wind speed, the rotor diameter, and its operational RPM, we can calculate the tip speed ratio. So that one we got 2 pi Rn by 60 divided by V. So here R is the radius at the speed ratio, R at which speed ratio is calculated. That is the radius, N is the RPM, and V is wind speed in meters per second. Okay. So here we made 60 because it's per meter per second. So to make that, generally RPM is rotations per minute. To make it as per second, we have divided by 60. Okay. And the next topic is wind shear. Wind speed usually increases with the height, with elevation. This phenomenon is called wind shear. Means in the ground, whatever air we get is very low speed. If we increase our altitude, that higher wind speeds will be more. Okay, so that phenomena is called wind shear. The ground causes friction, so the wind travels slower near the ground, rubbing against the ground. The wind speed will get slowed down. Okay, so do we have one formula like what is the velocity at certain height? If we know the velocity of the wind at a given height, if we want to know the velocity of required height means, then we using this formula or this formula. Both are same only, but a different approach. Means this one we use the logarithmic height. Here we use the shear component, wind shear component alpha. Any formula you can use to find the velocity of the unknown wind speed. Okay, these are the two formulas. Any formula you can use it. And which the form here beta is given from this range to this range. Here alpha we have can use different locations. For different locations we have to choose the alpha value. Means hard ground or lake or ocean means 0.1, short grass or until soil means 0.14. If it is a more buildings or more trees are there, then alpha we have to use choose 0.22 to 0.24. So based on the location, we have to choose the alpha value here. If we don't know all these things, then we can choose the generally recognized rule of thumb. The wind speed increases 1/7 of the power of the height above the ground. If we don't want to use all these formulas, then we use this rule of thumb, means 1/7 of the power of the height above the ground. Like this, we can use this generalized rule of thumb, and we can calculate the speed, wind speed at required height. And two problems also examples are given, like whatever we calculated, this power is the power production from the wind, all those things, and this tip speed ratio based on those two formulas. Example problems I have given. So it's simple, just substitute and calculate only. There is nothing complex. Okay. A horizontal axis wind turbine with a 30-meter rotor diameter produces 1 megawatt electricity at a wind speed of 60 kilometers per hour. Then what is the blade tip speed uh, and overall percentage conversion efficiency of the wind turbine? We have to calculate the both. So blade tip speed is equal to 4.25 into 60 into 1000. If 1000 means here 1 megawatt, so we have to make that 1 megawatt into kilowatt, so that is 1000. And here the speed is given in 60 kilometers per hour, so we have to make it in hour meters per second, means we have to divide it by 3600. Okay, so then we got the blade tip speed as 70.833 in meters per second, 255 to 254 kilometers per hour. If it is in kilometer per hour, this is the value. If it is meter per second, this is the value. And the area is pi r square, 3.14. R is the radius 30, rotor diameter. Sorry, here diameter. 30 is diameter. So this is d by 2. So d by 2 into d by 2, d by d square by 4. So here area we got like this, and velocity is this one, both kilometer per hour and meter per second. So conversion efficiency will be around 50%. From the given inputs, we got the 50% efficiency of the wind turbine. And this is another problem example. So this is the graph with respect to speed versus height. So if height increases, the velocity will be like this in the parabolic form, means velocity will be kh square. Based on this equation, that velocity will be calculated if for the given height. Okay, so here power, how we calculated is based on same this equation only we used. This 0.37 into mechanical efficiency, electrical efficiency, transmission efficiency into velocity by 10 cubes. Same formula we used here. Okay. So here we got efficiency 0.37, 0.9 is the efficiency for both electrical and mechanical, 0.9 into 0.9, and transmission efficiency 0.52, and we got the velocity 10. Sorry, we have to find out the velocity only. Here we got the power 10 kilowatt per meter square. So what we have to find out is velocity. From the velocity, we'll come to know what is the height. Height is 6.32. Okay, this is also simple problem only. So now we go to the next topic. So wind turbine modules. So we have two types of wind turbines. One is onshore wind turbine, one is offshore wind turbine. So for onshore wind turbine, these are the components will be there, like the blades, hub, nacelle. This is for this portion is nacelle, tower, foundation. And for offshore also same thing. Only thing is instead of foundation, we get the transition piece. This yellow portion is the transition piece. Okay, so blade, hub, nacelle, tower, transition piece. So inside this nacelle and hub portion, we have this gearbox. Means this rotor will be there. These are the blades. This bigger one is the blade. This the three blades are joined to the hub. The hub will hold the three blades, and this entire thing will be mounted on this nacelle. Okay. So inside this nacelle, we have low speed shaft. Whatever the blades shaft connected to this blade will be low speed called as low speed shaft. And we have one gearbox also will be there. From this low speed shaft, the gearbox converts transfer the energy to the generator. And we have other controls also will be like anemometer. So based on the direction of the wind, this anemometer and this wind vane, I mean this anemometer will give the wind speed, how much speed the wind is coming. So this anemometer input is more important for this wind turbines because we have two conditions in the wind turbine. If the wind is less than the rated turbine, then also the wind turbine will not work. And if it is more than the capacity of this wind turbine, then also this wind turbine will not work. So to safeguard this wind turbine, this anemometer input is required. So if the wind speed is within the range of this wind turbine, then only this wind turbine will work. Otherwise, they will automatically shut off this wind turbine. To safeguard this wind turbine, they will shut off. Even during what we called lightning or a heavy, what we call heavy rains. During heavy rains, that at that time also the wind speed is huge. That much huge, it's more than the capacity of wind turbine. Then that controller will switch off this, shut off this wind turbine, and it will brake also. Brake will be applied so that it cannot rotate. So for that, brake is there. Brake is required, important. And this yard drive rotates this facing this wind turbine. This yard drive, with the help of this yard drive, we can swivel this wind turbine wherever the wind speed is more, that this entire thing will face to that direction. For that one, we have this yard drive. So this wind turbine is very bulky. That's why To drive this drive, we need motors also. Okay, and these are the common things, uh, important components in the nacelle and hub area. Okay, and other than this one, and we have tower. Here, whatever my in energy domain experience, entire my experience in the tower only. So in the tower, so many platforms will be there, ladder. Like so many components will be there, like ladder. This is the ladder. So people who are working or who are installing the wind turbines, they have to choose lift or ladder. Both they have to choose to reach the nacelle portion. Okay, so for that ladder is there, lift is there, damper will be there. So this wind turbine is too huge, and height is also very more. So due to high winds, it will swivel. That entire wind turbine will swivel. So to reduce that vibration and oscillations, damper also required. So damper will be there. The damper will be near to this nacelle only. Near to this height only, the damper will be there. And the lift platform will be there. Damper service platform will be there. And cable loop platform will be there. Cable loop platform is nothing but from this generator to this transition piece, or to this foundation, one cable will pass on this, because the whatever electricity generated in the generator, that energy is transmitted in the cable. That cable will be huge size. It's like anaconda size. You can consider one anaconda as one cable, that much huge it will be there. That control, I mean, that transporting that cable itself is a very tedious task. Okay, high voltage cable, lift beam platform. Yeah, for this inside this tower, one lift will be there. That lift also operation, one beam is required. So that lift beam also there. For that to work on this lift beam, one more platform also will be there. And I told right, inside this tower, damper will be there, right? The damper will be two kinds of dampers are there. Previously, we used this tuned mass damper. This tuned mass damper looks like this. So this tuned mass damper working principle I will explain 1 minute. See. One minute. We have breaks. See, this is the tune mass damper. So this is the pendulum kind of thing. So that pendulum kind, 1 minute, it's not clear. 1 minute. See, if you consider this as one tower and this as one tower, so if heavy wind is coming, then it will oscillate easily. Then well, if we use the damper, then these oscillations will be reduced. See, if the water which it's having water, so that oscillations reduce. It says empty tower, so oscillations will be more. So on this working principle only, the dampers will work in the wind turbines. Okay. Same, this is the working condition, I mean working principle in the wind turbines. Same principle they use it to create the damper. So I have worked on this large damper, same working principle. So whatever I have designed damper will be in the cylindrical shape. One more picture will be there that I will show. Yeah, see, like this will be there, the damper. So it will be circle shape. That one, all the, it's like Disk will be there. That damper will be formed of the disk. The disk is stacked one over the other. Like here five, here five. They will place one disk over the other disk. So inside the disk, they will fill the water. So just now I shown right, same principle, it will reduce the oscillations in the tower. Whenever high speed wind is coming in this tower, it will oscillate like this. To avoid that oscillations, we require damper. So the damper will be inside this tower portion, in this around this height. Actually, I did not got the real pictures because whatever I'm working is even more damage, more size of the damper because that is official, so I cannot bring the same pictures here. So whatever available in the Google, I tried to explain here only. So, but I think you got some idea how the damper works. So this is the same way. If more damping is required, same stack two times they will put. Means like suppose here one row and same again two rows if required, three rows if required, four rows. So like that, here one platform, here one platform, here one platform, here one platform, like that they will stack one by one over the other. So that if the damping effect is required is more, then they will use four platforms. If less damping is required, then they will only use two stacks. Like that damper will be used. And this is the foundation. So for offshore wind turbines, this is the foundation. This requires huge area, and they want more area to stabilize the tower. So this is how they will do the foundation. Okay, so next is the lift. This is the generally what the lift we used inside the turbines, means inside this tower portion. Inside this tower portion, we use this lift. This lift carries only 2-3 members max, and always if the always based on the capacity means 240, sorry, not 240, it's like 186 kg load they can lift. So that lift platform will be from this portion, means from the entrance to the topmost platform will be there. Till there it can transport luggage or people. This is the lift we use. And what I want to explain here is, suppose you are understanding how the wind energy works, how the hydrogen is generated. All those things you will come to know. You overview you know, but as an engineer, what you will work if we go to some company and that company works on this renewable energies. What is the work? What is your scope? Will be like this. You have to design entire tower. Means the tower contains so many sections. Suppose so one by one they will place it over one by one. Okay, so this will be tower will be like four sections. One is top section, mid section, mid one, mid two, and bottom section. So whatever they design, you have to design entire tower portion. Inside the tower portion, you will have the platforms. So you have to design the platforms. In the each section, at least 1 to 2 platforms will be there. And that I will show the platforms. See, this is the platform. See, about this one is the platform, and the whatever people are standing right, that also a platform. People standing on this platform and fixing these nuts and bolts, right? That is service platform. We call this one. This platform only meant to tighten these bolts. this bolts view where it will come like this. To join one section of the tower to other section of the tower, this entire bolts will be there. To join this one more, we have to stand somewhere, right? To stand somewhere, we need a platform. That platform will be like this. So on this platform, we have to stand and we have to fix all these bolts. And actually, they will keep one tower over the other tower, like I shown, right? Like that, they will place one tower over the other tower. So after placing one tower to other tower, like this, they will place it and they have to bolt 360 degrees, they have to bolt it. So to bolt that one, they need one platform. Sorry, here this platform that is called service platform. So this service platform will have so many beams to design the platform. So all the beams we have to design, and they will give the input like how much the diameter of the tower and what will be the platform purpose. They will give all those things. Based on that, you have to design the platforms and you have to design these layer systems. This is the layer systems and this is the electrical cable routing. So you mechanical people only have to route all these electrical routings inside this one, and you have to do the lighting systems. Means whatever the lights required inside this tower, you have to make the lighting system. Lighting system. So you have to do that one. Okay, this is the thing what I want to explain to you. So if you have any queries, please let me know. Or if any more information you want, also you let me know. I will explain.
Thank you, Sethuram. Dear participants, any queries?
If you feel any link is missed, also let me know. I will.
Your voice is very low, Sethuram sir.
My voice is very low.
And there is another background, some disturbances.
Is it?
Like displays, I think.
1 minute, 1 minute. You could have tell before only I can set that one.
Yes, yes.
1 minute, I will adjust that one.
Any queries from the participants? I request all of you switch on video for taking a snap for AICTE portal upload. Sethuram sir, switch on video.
Yes. Yeah, okay.
And stop sharing.
Okay. 1 minute, 1 minute. Oh, it's very slow for me. Wait, I've gone to somewhere.
Sir,
Good afternoon.
this is Mallikarjun. So you explained about the conversion of wind energy to the green hydrogen, but production
Yes.
of hydrogen requires high density electric power.
Yes.
But wind energy can't produce such a high density and consistency of electric energy. Then how we can balance the production of green hydrogen?
No. Actually, whenever it is available, at the time only they will produce the hydrogen, not continuously 24/7. So suppose it's only one wind turbine won't be there, right? It will have so many. It will be spread over the entire area.
Okay, sir.
So that's why you will for each wind turbine you will get your rated capacity of wind energy. Suppose 1 minute I will share one more.
Good evening, sir.
Yeah, good evening.
Sir, myself, Dr. Suresh. I am from EEE department, sir, basically.
Okay.
Myself also working on renewable energy integration to production of green hydrogen, sir.
Okay.
Sir, actually, in order to implementation, what are the challenges we may face to produce green hydrogen from renewable energy sources? What are the softwares generally we may use for designing model? What are the softwares are better? Like that, I have so many queries, sir. So kindly
Okay.
suggest
Yeah, we use NX only for the design softwares and ANSYS for the analysis purpose.
which software, sir?
NX.
NX.
See here, if we take one wind turbine, the rated speed is, rated power is 3.2 megawatt.
Okay, sir.
So from each wind turbine, you will get 3.2 megawatt. So like that, so many wind turbines will be there. So it's not an issue. You will not get enough sufficient power. You will get sufficient power to
Sir,
generate it.
actually, the problem is to convert wind energy into electrical energy. There is some kind of losses are arising.
Yes,
Again,
yes, correct.
to convert that electrical energy into again green hydrogen, again it
Mm.
may exist some losses, sir.
Yes,
Then
yes,
whether it is benefitable or any advantage, sir. So many losses are existing in the conversion stages.
yes. Yeah, for each and every conversion stage, losses will be there.
Yes, sir. How
We
can you overcome those?
no, that losses reduction will be time to time. Means suppose this is the one specific kind of the wind turbine. So for the next one, they will take all the inputs, what are the losses, and they will check the what are the technology advancements are available. So they're considering all those things. They will design a efficient one, more efficient things. They will do. I mean, whatever that they will consider more inputs. Means more advanced technologies they will use to design a new latest wind turbine. I, I think you got the answer. Means suppose now we are using with some available technology, we will design some wind turbine. For next version, we'll use advanced technologies. So time to time that for latest design will have more efficient than the previous ones. You will not get an entire thing in one at a shot. I mean to say.
Sir, is there any prototype model available at any research institute, sir, for this type or model?
Prototype is available, but not in institutes. Actually, in India, Kurnool, I think so many wind turbines are there. Generally, we company people visit there. Kurnool, so not Kurnool,
Yes,
Nellore.
sir. Only wind power plants are available, sir.
Mm.
I am wind energy to hydrogen production. Like that, plants are available or not, sir, in
No,
India.
that even I am not aware of those things. That wind to hydrogen still one by one is coming. It's not entire thing is not at. In India, I have to check it. Even I have to check it. I'm not sure where it is available.
Okay.
Yes, Dhanraj.
Thank you so much. On behalf of Department of Mechanical Engineering, Leclerc Baledi College of Engineering, I extend my sincere thanks to resource person Sethuram sir for insightful presentation on green hydrogen generation from wind energy. So you explained in detail about what is wind energy, how to generate wind energy from wind turbines, different types of wind turbines, and also the possibilities, necessity for sustainable energy solution for a better future. So thank you once again, Sethuram sir, for the uh, time you spent to share your expertise with us.
So whatever you understand the overview of the wind energy, right? Wind energy, hydrogen energy. So as a fresher or as a new graduate, what is your scope for this one to contribution? So there are different ways you can contribute to develop this wind energy or hydrogen energy, whatever you will do. Like you can suppose there are so many companies working in the wind energy domain, like Siemens, GE, Inox, and in India we have at least 4 to 5 companies are there. So what they are offering is like design. They want CA expert, means analysis expert, CAD expert, as well as manufacturing expert. So you have at least any of the things like for design, like NX modeling software is NX. Using Siemens NX, you can become a CAD engineer in these companies. You can design so many components like I told, right, like platforms, ladder systems, damper systems. So you have to work any of the systems. So in my experience, what I have worked is platform systems and damper systems. In that, what I have done is that CAD designs. I have done all the beams, all the floor plates, all the uh, stays. Means for platform, so many things are required: beams, floor plates, stays, and after designing entire beam, we have to make sure that it can able to transport, it can able to assemble, it can able to manufacture, it can able to service. All those things you have to consider. It has to be serviced, it has to be transport, it has to be manufacturable, it has to be installed, it has to be installed. All those things you have to consider while designing the any component. So any company, they will ask few things. One is safety. Whatever you design, you have to meet the safety standards. Whatever the second one is, whatever you design, it should be high quality. That is the second requirement. Then third requirement is on time, means based on the schedule you have to complete the project. That is the on time. Then fourth thing is you have to complete within the given the cost. Means for any world class component, class company, the engineer has to fulfill these four requirements. First is safety, second one is quality, third one is on time delivery, and fourth one is cost. If you satisfy these four requirements, you are a very good engineer, very good project manager. So to meet all these things, you need domain knowledge as well as skills, tool knowledge. Domain knowledge is why we are working. I mean, suppose you are designing one component, where it will be used, how it will be used, where it will get assembled, how it will be useful to the system. All those things you should know. That is domain knowledge. And skills means like CAD skills, analysis skills. Means CAD means you have to tell the size, fit form function, means how it will get assembled, what is the form structure, like straightness, parallelism, perpendicularity, all those things, form, what is the form, and function, how it will function, fit form function, they will check it in the CAD. And whatever you design, that is good enough to withstand the given conditions of load conditions. So for that one, you have to do the analysis. That FEA analysis will be done using the ANSYS software. So if you are more interested in analysis, then you should know the ANSYS software, and you should know the stress strain curves. Means you should know the topics called failure mode analysis, and you should know the topics called Soderberg equation. One more is Soderberg equation. I forget the failure mode analysis. Actually, those failure mode analysis also you should be good at all those things, and you should know the FEA, and you should know the strength of materials topic. These three are required for the analysis purpose. And if you are not good at drawing and not good at analysis, then you should be at what we called project management. So within the given timelines, you have to complete the project. At least you should be in the manager position, so that you should guide the designers, means work assignment, all those things. But for becoming manager, you should be become first engineer only. Then only you can become the manager. You directly cannot become the manager in the engineering field. You have to work as a basic engineer. Then only you can become the manager. So that is you can rule out. So you have to start your career as a CAD engineer or analysis engineer or CFD engineer. Any three engineers, then you have to become a manager. I forgot about the CFD. Means to design this wind energy blade, you need the CFD skills. You should design the blade based on the given airspeed, and I'm not good at CFD, but CFD analysis also required. That skill also required. Generally, for all the companies, these three are required. One is CAD, one is analysis, FE analysis, one more is CFD. These three are required actually.
So any queries from the participants?
So if any fresher is going to start his career, everyone they will ask is about your project. Project will be like what is your project and what is your contribution in the project, and what are the skills you use to complete that project, and what are the challenges you face to complete the project. All these are basic questions from the your BTech project. Okay, what is the outcome, what are the challenges you face, how you overcome all those challenges, what is your contribution in the project.
So if there are no questions, so we will close the session. Okay, thank you, Sethuram, once again for your insightful presentation on wind energy. Thank you.
Thank you, Dhanraj.
Yeah.
Thank you, everyone.
So thank you, one and all, for your nice participation. Thank you.